Hey, what's going on, guys? This is Mr. Plunkett, and I can't be at school today, so I'm just going to go over a couple of the problems from our homework for 4.7 piecewise functions. It's a pretty tough section, so we are going to go over just some of the problems just to help you out. Okay, so the notes we went over piecewise functions and step functions. Um, you can use your notes to answer that first question and even that second question. Um, it's not that bad. Piecewise function for like an absolute value function, like number two, you can see that there would be two different functions that, a V-shaped absolute value graph essentially has two different sides. It has this line to the left and it has this line to the right. And so you could write this as one function, f of x, for instance, and then you would have two different pieces. You'd have one piece for the red, and I'm going to write this in blue, which is kind of weird, and one piece for the blue, and then of course you'd have the restricted domains. I guess that's not a semicolon, I meant to do just a comma. You'd have the domains for each of those. So the red would be to the left of the vertex, and the blue would be graphed everything to the right of the vertex. But I think you'll see more of that by looking at some of these other examples. So like number 12. So remember, it's one function, g of x, function g. And so if you're finding g of 5, what you need to find is you need to go through all the domains and you need to see which one of those has x equals 5. So when is x equal to 5? It's actually in this one, because if 5 is greater than or equal to 2, so what you're going to do is you're going to substitute 5 into this piece, 2x minus 5. You wouldn't substitute it here because it's not in this domain. Wouldn't substitute it here because it's not in this domain. So you'd substitute 5 into that piece to determine what the output would be. Okay, same thing with this. You have a trip, total distance in miles, and x hours is represented by piecewise function, so distance given x hours of driving. You find where 4 is in the domain. Which one of those has 4? You can see it's the bottom piece, and so you would substitute that in to that bottom piece to determine what the distance was that was driven in 4 hours. Okay, I'm just going to continue on here and then identify the graph of the function and the description of the domain and range. So we have y equals 2x if x is less than or equal to negative 3, and y is equal to negative 2x if x is greater than negative 3. So it looks like negative 3 is the place where we have this division between the two pieces. And so what we need to see is if x is less than or equal to negative 3, we have a line that's y equals 2x. Well, let's look at some of these. I think this one's an interesting one. These two are interesting because when x is less than or equal to negative 3, that's all of the values that are over here, right? And so this right here should be this top piece. But notice, what is the slope of this piece? It's actually negative. It's going down from left to right, whereas the slope for the top piece is actually positive. It's positive 2. So it should be going uphill from left to right. So we can eliminate this bottom left one. And we can also eliminate this bottom right one because it's the same problem. Because the piece that's x is less than or equal to negative 3, also or equal to, that should be a solid dot, right? So that's for sure something is going horribly wrong right there. So that means it's one of these two. That already puts us in the ballpark here. And so all we need to do is figure out which one of these has a slope of 2. And you can see that they're actually counting by 4s here, which is a bit confusing, and a lot of students get confused by that. To find the slope, you need to pick 2 points. It looks like we have a point right here. And then we actually do have a point there, but maybe I'll use this one right here. Okay, and since this is going by, I guess, negative 2s, negative 4, negative 6, negative 8, negative 10. So this point has a point at negative 10, negative, let's see, this is 4, 8, 12, 16, 20, negative 20. And this point has a location of negative 6, comma, and that's negative 12. Okay. So from negative 20 to 12, from negative 20 to 12 is positive 8. That's the change in y. Over from negative 10 to 6, that's positive 4. So that has the right slope. So far, so good. And then at -3, you have the less than or equal to, you have the closed dot, and then you have the open dot, which is trending down. So now we should have a slope of -2 for this red, I'm going to make it red line. So that slope's correct. This slope, red line, you can just pick 2 points, same thing, 0, 0 looks like a good one, and that's 4, -8. So we have 0, 0, and 4, -8. Okay. So this slope looks from 0 to -8, that's -8. From 0 to 4, that's +4. So that's -2. So that looks like it's the correct graph. It looks like that's right. And in fact, it doesn't appear to me obvious what's different between the two graphs. The graphs look like they're the same. So these graphs are correct. Now, what about the domain? Is there any restriction to what we can substitute in for x? No. So it's got to actually be this one, right? Because the domain is going to be all the real numbers, and then the range is all the y values that are less than 6. So you can kind of just piece that out. I went over a lot more detail than you'll probably need to do this, but that's just an example for number 16. 18 is very much like 16. So is number 22. And you can see what you're just going to correct the error. So it's just going in the opposite direction. Okay, how about this one, writing the piecewise function? And writing the step piecewise function for the step function right here is really the same thing. So we're just going to use this right here. Let's do this and see if we can figure it out. So it looks like we have 2 pieces, good, 2 pieces, and we always start with the domain that's to the left, and then we move to the right. So it looks like we have a domain that is to the left and equal to 0. So that's going to be x is less than or equal to 0. So here we would write x is less than or equal to 0. And the domain for this other piece, which we'll highlight on the x-axis as red, notice there's an open dot. So that's going to be x is greater than 0 because that point is not included. Okay, now what we have to do is figure out the equations of this line. So every y value looks to be -3 to me. So that means you would just say y is equal to, what that was supposed to be a y. Y is equal to -3. And then this line, it's the y-intercept appears to have been 3. So that's +3. By the way, that's a y, if you can believe it. And this right here has a slope of, well, let's see, if we pick this point and this point, that's down 3, right 1. That's -3/1. So that'd be -3x plus 3. And then we have our 2 graphs. The red one's really the top one and the blue one's the bottom. Just to illustrate that, to make sure you guys see, f of x is equal to, wait, I did that wrong. I meant to do this one, blue one at the top, and red one at the bottom. So blue is this piece right here, and the red is this piece right here, going to the right. Okay, let's go ahead and move on through. I think the step function is very similar to the one we did on the notes. If you didn't get the notes, try to figure it out based off of what's here. You can see that this point right here, y equals 4. In fact, I can show that to you. Y is equal to 4 when x is between 0 and 1, and it's less than or equal to 1 because it's a closed dot, and it's less than x with the 0 because it's an open dot. But I think you guys can handle that by sorting it out, just logicking it out. Okay, this one, same thing. I think you can figure that one out. This one, actually, same thing. It's not very hard to figure out as long as you are paying attention to, this is the number of copies down here, and this is the total cost right here. So those y values are going to be total cost. And what costs more, 100 or 101? So you'll have to see here what's going down. I think you could probably see it. There's an open dot and closed dot. That's going to matter. Okay, moving on. Okay, how about this? Explain why this piecewise function does not represent a function. I'll give you a hint on that. Notice that x is less than or equal to 3 and x is greater than or equal to 3. That's a problem because that means that the number 3 will be substituted into both pieces, which means you could have 2 outputs for 1 input, which is illegal. So the rest of the questions are just review, which is like graphing lines and that kind of thing. So hopefully you'll be good on that. Please email me if you have any questions. Thank you all for your patience, and hopefully I'll see you soon.